Number 11 asks us to solve an exponential equation. We have an e in there, so we're probably going to use the inverse of e to the x, which is the natural log function. To do that, let's try to get this exponential term by itself. And the first thing we can do is divide both sides by 6. If I divide both sides by 6, I get 4 equals e to the 0.03 t power. Okay, here's where the inverse function comes in. Remember that if we take an inverse function and do a composite function with its inverse, it's going to eliminate that function. The inverse of e to the x is going to be the natural log. I can take the natural log of both sides. And that's going to leave me with the natural log of 4, which I can calculate. ln of 4 is going to be 1.386. 1.386. The natural log of e to a power is just this power left over. So 0.03 t. My last step, I can divide both sides by 0.03, and I get a result that's 46.20. It's actually going to round to 46.21. It's 46.2098 equals t. Number 12 asks us to solve an equation for the unknown variable. In this case, we're dealing with a logarithmic equation, which means we're going to have to use the inverse of the common log. We know that the inverse of the common log is going to be 10 to the x. So if f of x equals log x, its inverse is going to be 10 to the x. We say a lot that inverses undo each other, which is more or less the case, although a less mathy way to say it. Let's start by getting the log x all by itself, and that means we have to get rid of this negative. In part, it's just going to make the problem a little bit simpler later on if we get rid of that negative now. A quick way to do that is multiply both sides by -1. And I'm left with log of x equals -2.3. Okay, here's where that inverse comes in. If I raise both sides to a power of 10, 10 to the log x equals 10 to the -2.3. Well, that 10 to a power and that log x are going to cancel each other out, leaving me with x. And on the right side, I can use my calculator. I did second log, which gets me a 10 to the power of x button. I could also have typed 10 caret and then used parentheses. The second log is a shortcut and also reminds you that they are inverse functions. And I'm going to type in -2.3, close parentheses, and I get my answer of 0.005. Problem 13 is asking us to apply an exponential model and find a way to handle some problem-solving thinking with it. We're going to start by taking a look at the problem. So you invest $13,500 in a mutual fund with a projected APR of 4% compounded continuously. The most important part here is this phrase compounded continuously, because that tells us which exponential growth based on interest formula we're going to use. to compound continuously, we're going to use A equals PE to the RT, where in our case T is going to be based on number of years, R is our interest rate, in this case 0.04, 4%. P is going to be our initial amount, our principal. And A is going to be how much we have after we compound the interest, our final value. The first question is, how long will it take you to triple your money? And that can be kind of an abstract question because we don't talk about how much money you invest. The first thing that we can do is say, okay, if I start with P and I triple my money, that's going to end up leaving me with 3 times P. So I have an initial value of P, a final value of 3 times P. I fill in the rest of my exponential growth formula. PE to the RT. I know that my R is 0.04. So now we're left with one equation with 2 variables. Thankfully, if I try to get this expression e to the RT, or e to the 0.04t, by itself, very quickly I can see that my p's are going to go away. P divided by P equals 1. P divided by P equals 1. And that leaves me with 3 equals e to the 0.04t. To solve an exponential function in base e, we're going to use the inverse function, which is ln. Take the ln of both sides. So ln of 3 equals ln of e to the 0.04t. ln of 3 1.099 equals ln of e to the 0.04t is going to leave me with 0.04t. If I divide both sides by 0.04, I'm left with 27.47. So I divide by 0.04. T equals 27.47. That means it will take 27.47 years to triple our money at a 4% APR. If I look at the second problem, it's pretty similar to the first one. In fact, I could set it up in exactly the same way. This time, instead of 3 times P, I'm going to have 9 times P equals PE to the 0.04t. You can probably see that this is really going to result in 9 equals e to the 0.04t. And when I take the natural log of both sides, ln of 9 equals ln of e to the 0.04t. That's going to result in 2.197 equals 0.04t. Divide by 0.04, and I've got 54.93. 54.93 equals t. Do you notice something interesting about that? 54.93 So it's 54.93 years is exactly twice 27.47. In fact, if we think about that, it makes sense. If after 27 years our value triples, when it triples again after 27 more years, if we multiply those multiply those triples, we get 9 times. 3 times 3 is 9. So that makes sense based on the numbers we got. The last question is, how much money will you have in 30 years? If I go with 13,500, we don't know how much we have in 30 years, times e to the 0.04. Our t is going to be 30. I can actually type this expression entirely in on my calculator. 13,500 times e to the x is the second function of the ln button. That also helps you remind yourself that they're inverse functions. So e to the 0.04 times 30, and I'm going to close my parentheses. And I'm left with 44,821 and 58 cents.